Ever wondered how weather behaves in space? Well, you're about to find out. Imagine solar flares erupting, coronal holes releasing solar winds, and the fascinating play of forces that shape our celestial neighborhood. This isn't just about starry spectacles, it's about understanding the impact of space weather on our own planet. We'll delve into the intricacies of solar flares, explore the mysteries of coronal holes, and examine how space weather influences Earth. So, buckle up and let's dive into the fascinating world of space weather. First off, we have the spectacular solar flares. Solar flares, for those unacquainted, are sudden eruptions of intense high-energy radiation from the sun's surface. Think of them as the sun's equivalent of a volcanic eruption, but instead of spewing lava, they release a burst of radiation across the entire electromagnetic spectrum. These flares occur when magnetic energy that has built up in the solar atmosphere is suddenly released. Picture it like this. The sun's magnetic fields twist and turn, creating a kind of magnetic knot. When this knot becomes too strained, it snaps, releasing a huge amount of energy. That's your solar flare. Now, why should we care about solar flares here on Earth? Well, while they're a fascinating spectacle, they can also have real-world implications. You see, when a powerful solar flare hits Earth's magnetic field, it can cause geomagnetic storms. These storms can interfere with our satellite systems and even power grids. Just this morning, we experienced an M-class solar flare. This sits in the middle of the solar flare classification, between the less intense C-class and the most intense X-class flares. An M-class solar flare, like the one we saw, can cause brief radio blackouts at the poles and minor radiation storms that might endanger astronauts. This particular flare was an impulsive event from the northern departing active region. Luckily for us, there was no coronal mass ejection, CME, associated with it, and it was aimed away from Earth. But it's a stark reminder of the power our sun holds and the effects its activity can have on our planet. So, while we admire the awe-inspiring spectacle of solar flares, we must also respect the force of our sun and the potential impact of its activities. Understanding and monitoring these phenomena are crucial in our increasingly technologically dependent world. Impressive, isn't it? But wait, there's more to come. From solar flares, we shift our gaze to the intriguing world of coronal holes. These are areas on the sun where the solar magnetic field extends into space, rather than looping back onto the solar surface. It's like a celestial highway, allowing solar particles to zoom away at high speeds. Coronal holes are major players in the space weather game. They spew out high-speed streams of solar wind, which is a stream of charged particles released from the upper atmosphere of the sun. This solar wind can create a disturbance in Earth's magnetosphere, leading to geomagnetic storms. And these storms, my friends, can have a range of effects on Earth. From auroras that paint the night sky with ethereal beauty, to disruptions in satellite communications and power grids. Now let's talk about this incoming coronal hole that's on our radar. As it turns to face Earth, we anticipate a surge in solar wind. This could kick off an earthquake watch and might lead to some impressive auroras for those of you lucky enough to be in the right place at the right time. But it's not all light shows and seismic activity. There's a chance this solar wind could impact our technology. Satellites, GPS systems, even our power grids could potentially feel the effects. However, our modern infrastructure is robust and designed to withstand these solar temper tantrums. But it's a gentle reminder of just how interconnected we are with our star, the sun. The solar wind from this coronal hole is expected to arrive towards the end of the week. And while we can't predict with perfect accuracy, we can certainly prepare and marvel at the cosmic ballet unfolding millions of miles away. Coronal holes, with their high-speed solar wind streams and potential to stir up geomagnetic activity, play a crucial role in our understanding of space weather. They are a testament to the dynamic and ever-changing nature of our sun, and they remind us of the profound influence our star has on our planet. Coronal holes, another fascinating aspect of space weather, wouldn't you agree? Now, let's take a look at some of the recent happenings in space weather. A major news item that has been making waves is the volcanic eruption in Iceland. This isn't just any ordinary volcanic eruption, folks. This is an eruption of cosmic proportions, spewing lava in virtually all directions from the eruptive zone. It's the largest one in the current sequence so far, and it's been lighting up the internet with its awe-inspiring display of Earth's fiery might. But what does a volcanic eruption have to do with space weather, you ask? Well, volcanic eruptions can have a significant impact on our atmosphere, influencing weather patterns and climate. They can even interact with solar radiation, adding another layer of complexity to our understanding of space weather. Next, let's move on to a major study on solar forcing of weather. This study is a game changer, folks. It delves into the rapid electrical forcing of the lower atmosphere and weather by solar activity, and how the ongoing magnetic pole shift is amplifying these effects. All these processes work through the global electric circuit, a fascinating concept that links space weather with our Earth's weather. This study offers an outstanding analysis that shows major changes in near-ground conditions relevant to convection, storms, and temperatures caused by solar storm activity. These changes are centered around the rapid fluctuations in the atmospheric electric field, all forced by the space weather electromagnetic influence. It's a testament to the ever-growing understanding of how our star, the Sun, plays a pivotal role in shaping our planet's weather and climate. As you can see, space weather is a dynamic field with constant updates, from fiery volcanic eruptions to groundbreaking studies on solar forcing. The realm of space weather continues to surprise and intrigue us. It's a reminder that we're part of a larger cosmic system, with the Sun's activity playing a crucial role in our everyday lives. Lastly, we'll delve into the intriguing concept of the global electric circuit. Imagine the Earth wrapped in a colossal electrical network, a circuit that connects the atmosphere, the planet's crust, and the ionosphere. This is the global electric circuit, an integral yet often overlooked part of our planet's intricate system. So how does space weather factor into this? You see, our star, the Sun, is a powerful generator of electromagnetic activity. Solar flares, coronal mass ejections, and other space weather events emit charged particles and electromagnetic energy that travel across space and interact with our planet's magnetic field. This interaction influences the global electric circuit, altering the electrical properties of the Earth's atmosphere and surface. Now let's add the ongoing magnetic pole shift into the mix. The Earth's magnetic field is not static. It's continuously changing, shifting, and at times, even reversing completely. This magnetic pole shift can amplify the effects of space weather on the global electric circuit. As the magnetic poles shift, the way our planet interacts with solar electromagnetic energy also changes, leading to potential variations in the global electric circuit. These changes can have a ripple effect on various aspects of our planet, from weather patterns to technological systems. For example, changes in the atmospheric electric field can influence cloud formation and weather patterns, while fluctuations in the Earth's surface electric field can affect our power grids and satellite communications. It's fascinating, isn't it? The Sun's activity millions of miles away, coupled with shifts in our own planet's magnetic field, can influence this vast electrical network enveloping our Earth. The interplay between these cosmic and terrestrial factors, their effects on the global electric circuit, it's all part of the dynamic, ever-changing nature of our planet. So, when we talk about space weather, we aren't just discussing distant solar events. We're exploring a complex, interconnected system that spans from the surface of the Sun to the ground beneath our feet. The global electric circuit, another key player in the space weather arena. Well, folks, that rounds up our journey through space weather. We've traversed the vast expanse of our star's activity, from the impulsive solar flares that spring from the northern active regions to the mystery of coronal holes, those dark areas on the Sun where high-speed solar wind originates. We've seen how these cosmic phenomena can send shock waves in the form of solar winds hurtling towards our planet, sparking awe-inspiring auroras and at times causing disruptions to our technology. We've also ventured into the realm of the latest space weather news, keeping our fingers on the pulse of events like the recent M-class solar flare, the incoming coronal hole on the south, and the noteworthy CME released just yesterday. It's a dynamic, ever-changing landscape there, and staying informed is key to understanding how these events can impact us, both on a global and a personal level. Finally, we delved into the intricacies of the global electric circuit, an interconnected system that ties the weather on Earth to the weather in space. We've seen how solar activity can rapidly force changes in our lower atmosphere and how the ongoing magnetic pole shift is amplifying these effects. It's a fascinating field of study, one that underscores the interconnectedness of our universe. Remember, the next time you look up at the sky, there's a whole lot of weather happening out there in space. Stay curious and keep exploring.